Welcome to probability and probability distributions. The first part we are going to look at the probability, then the last one we look at the probability distributions. So what is a probability? I'm just defining the term probability. It's a measure of the likelihood of an event taking place. It's just the chance. What is the possibility of you coming late to class? And probability is ranging from 0 to 1. When you get probability to be 0, what does that mean? That you are very sure that event will not take place. And when you get it to be 1, you are very sure that event will take place. So events are denoted by capital letters, e.g. Probability of A, where A is the event and P just means the probability. So for you to find the probability of A, you just need the number of favorable outcome to A over the total outcome. That's why this probability cannot be more than 1. Let's look at the definitions of terms as used in probability theory. The first term is an experiment. What is an experiment? It's just a process that leads to one or several outcomes. A process that leads to one or several outcomes. E.g., when you toss a coin, that is an experiment. When you roll a die, that is an experiment. Then what is a trial? Is a single performance of an experiment. A single performance of an experiment. E.g., tossing a coin once, that's a trial. You have one trial. When you roll a die twice, that is 2 trials. So a trial is just the performance of an experiment. What is an outcome? This is the positive result. It is the result of an experiment, e.g., getting ahead in a tossing of a coin. When you get ahead in tossing of a coin, it is an outcome. So outcome in tossing of a coin is either head or a tail. Then we have the sample space. The sample space is the set of all possible outcomes of an experiment. All set of possible outcomes of an experiment. When you roll a die, remember, you have the 6 faces. 1, 2, 3, 4, 5, 6. So that becomes our sample space. What is event? It is a subset of the sample space. Event is just a subset of the sample space. It can include one or more outcomes. E.g., for example, let's say, what is the probability of getting an even number in rolling of a die? So even numbers is 2, 4, and 6. So these are even numbers of a die. The next terminology is the mutually exclusive events. Mutually exclusive events. So we are saying these are events that cannot happen at the same time. They cannot happen at the same time. E.g., getting a 2 or a 5 in a single roll of a die. You cannot get them at the same time. You first get 2 or first get 5, then later you get the others. So they cannot happen at the same time. We say they are mutually exclusive events. We have exhaustive events. Events that cover all the possible outcomes of an experiment. E.g., when you roll a die, the events 1, 2, 3, 4, 5, and 6 are exhaustive events. We have independent events. 2 events are said to be independent if the occurrence or non-occurrence of one does not affect the occurrence or non-occurrence of the other. So they are independent. Those 2 events are independent. They don't affect the occurrence or non-occurrence of the other. And we have dependent. 2 events are said to be dependent if the occurrence or non-occurrence of one affects the occurrence or non-occurrence of the other. We have conditional events. This is the probability of an event A occurring given that event B has already occurred. and it is written as probability of A given that B has occurred, which is equal to the probability of all of them occurring. This is probability of A intersecting B. That means all of them occurring over the probability of A has occurred. We have complementary events. These are pairs of events where one event happening means the other cannot happen. If A is an event, then its complement written as A with that /1 there means A complement, or just A raised to C. A complement is the event that A does not happen. Remember, probability of A plus the probability of A complement. The probability of A plus the probability of A complement should give you 1. The probability of A plus the probability of A complement should give you 1. And maybe the last but not least, equally likely events. Equally likely events, these are events with the same chance of occurring. Remember, when you toss a coin, head and tail have a 50-50% chance. All of them have a 50-50% chance of happening. Okay? So let's look at maybe some of the mathematical problems under this probability before we move to probability distributions. So this is our example 1. It reads, the probability that the bus A and bus B arrives at Kwetu town on a time is 3/4 and 4/6 respectively. Determine the probability that both buses arrive on time. Only one of the buses arrives on time. Neither of the buses arrives on time. Now this is how you solve. The probability of A, that is the probability of bus A arriving on time, is 3/4. Probability of A arriving late, that's why I've said A complement. Remember this one we said it means A complement. Will be 1 minus 3/4, which is 1/4. Probability of B, that is B bus B arriving on time, 4/6. B arriving late is 2/6. Remember this question, you can also do it using the probability tree diagram, of which if you want to draw a probability tree diagram, remember you have bus A and you have bus B. So bus A arriving on time is 3/4, then arriving late is 1/4. B arriving on time is 4/6, and arriving late is 2/6. So that is the tree diagram of this question. So let's answer both buses arrived on time. So that is probability of A and probability of B. That is 3/4 times 4/6, and you get half. Only one of the buses arrives on time. Only one, then let A arrive on time and B to arrive late. That's what I've said. A times the B complement plus. Now this time round, let B arrives on time, but A arrives late. And that is what I've done. 3/4 times 2/6 plus 4/6 times 1/4. And you get 5/12. Neither of the buses arrives on time means they arrived late. That is 1/4 times 2/6, and you have 1/12. It is as easy as that. It is as easy as that. Example 2 is here. The probability that Alice, Ben, and Celestine will be shortlisted for a job interview is 1/5, 2/9, and 1/3, respectively. Calculate the probability that from 1, all of them will be shortlisted for the interview. None will be shortlisted for the interview. At least one of them will be shortlisted for the interview. At least 2 of them will be shortlisted for the interview. This one also you can draw a diagram of it, but let's just calculate it this way. Probability of Alice is Alice being shortlisted 1/5. Alice not being shortlisted is 4/5. Ben being shortlisted is 2/9. Ben not being shortlisted is 7/9. Celestine being shortlisted 1/3, then Celestine being not shortlisted is 2/3. So all of them being shortlisted, that is probability of Alice, Ben, and Celestine, and I've gotten 2/135. 1/5 times 2/9 times 1/3. none of them, that is, all of them will not be shortlisted here now. 4 over 5 times 7 over 9 times 2 over 3, you get 56 over 135. At least one of them, at least one means just 1 minus none. At least one means 1 minus none. So 1 minus none is 56 over 135, you get 79 over 135. At least two. At least two. That means 2 or all of them. 2 or all of them. And all of them, we add 2 over 135. So let's do be shortlisted. So I've taken Alice and Ben be shortlisted, but Celestine not be shortlisted. That is what I've done here. Plus, now it is Alice and Celestine but not Ben. This is the Alice and Celestine but not Ben. Plus, now Ben and Celestine but not Alice. Then add all of them. You will end up with having 7 over 45. Can you do practice so that you get this question of probability? And I want also you to read more and look at when now the drawing is being done with the replacement. When drawing is done with the replacement, and when drawing is being done without replacement. And try to exercise. So now you can construct a tree diagram. Try to see how you can construct a tree diagram. Make your working on probability very easy. I want us to move on and look at now the probability distributions. So let's come to the second part of probability, which is called the probability distributions. We call it probability distributions. So in probability distribution, the variables are distributed according to some definite probability functions. And these are the concepts which are used in probability distribution. The first concept is a random variable. What is a random variable? This is a variable which takes specified values with specified probabilities. And we shall use capital letters to denote a random variable and the corresponding small letters to represent any specific value of the random variable. The second concept is a probability function. This is a function that permits us to compute the probability for any event that is defined in terms of value of the random variable. And these probability functions, they are only 3. Before that, let's look at the expected value. The expected value of a random variable is just the average value of a random variable. The average value of a random variable is what we call the expected value. So I've just said that we only have 3 most popular probability distributions which are frequently used. There is binomial distribution, there is Poisson distribution, and there is a normal distribution. So what is a binomial distribution? What is a binomial distribution? This is just a distribution due to James Bernoulli. James Bernoulli is just the name of a person. This is just the name of a person who was studying the probabilities. So it is a Bernoulli distribution which has more than one trial experiment. And the Bernoulli distribution is given by the probability that x is equal to x is p raised to x, 1 minus p, which I will denote it by q, 1 minus x. X is the random variable and p is the probability of success. Then the binomial distribution, this is how we are going to calculate. This is the formula we are going to use to calculate the binomial distribution. The probability that x is going to assume any value is n combination x. This just means n combination x. And combination is in your calculator. It is just below the alpha. Below the alpha button, there is a button there written NCR. Na juu yake ni NPR. NCR means combination and NPR means permutation. Those are just counting techniques. So it is n combination x, p raised to x, p is the probability of success, 1 minus p, which is the probability of failure, then n minus x, and n is the sample size and the number of trials you've done your experiment. So we have the characteristics of a binomial distribution. The first one, it is a discrete probability distribution. When I say discrete, that simply means this x is taking whole numbers. You're only taking whole numbers, 0, 1, 2, 3, 4. So it is a discrete probability distribution. The number of trials n and the probability success p are the parameters. In fact, you only need to identify what is your p and what is your n, and you are able to handle a binomial distribution. The mean is given by n times p. So when you take n times p, that will give you the average. The variance is npq, n times p times q, which is q is 1 minus p. The standard deviation is always the square root of variance. So standard deviation will be the square root of npq. The variance is less than the mean. Always variance is less than the mean. And if p and q are equal, then the binomial distribution is symmetrical. Otherwise, it is asymmetrical. So when p and q are not equal, then our distribution is asymmetrical. When p and q are equal, then it is symmetrical. Symmetrical means that it's just as the same shape on both sides. Let's take some of the examples and see how we can handle a mathematical problem involving binomial distribution. Example 1. So example 1. In the Juakali sector, the percentage of male entrepreneurs is 70%. So 70% are male entrepreneurs, 30% female. But our interest is, or our event here is the probability of a male entrepreneur, which is 70%. A random sample of 10 entrepreneurs was selected from the sector. Determine the probability of selecting 1 male entrepreneur, no male entrepreneur, at least 1 male entrepreneur, at most 8 male entrepreneurs. So as I said before, you only need to identify n and p. N is the sample size, so how many were sampled? 10 were sampled, so our n is 10. And what is the probability of success? Probability of being a male entrepreneur, 70% is the same as 0.7. So, Roman 1 is asking us the probability that x is equal to 1 male entrepreneur. Remember, from the binomial distribution, I said the probability that x is equal to x is given by n cx, p raised to x1 minus p, n minus x. So I'm using this to calculate my probabilities. I said this means n combination x. So n is 10. And x is 1. So 10 combination 1, p raised to x. P is the probability of success, which is 0.7 raised to 1. 1 minus p, that is 1 minus 0.7, you remain with 0.3. Then n minus 1, that is 10 minus 1, 9. So when you fill this in your calculator, I said this C means combination, and I've told you where it is in the calculator. You'll have this probability. So this is the probability of 1 male entrepreneur. No male entrepreneur. When there is no male, that means x is 0. So when there is x, put 0. That is 10 combination 0. 0.7 raised to 0 and 0.3 raised to 10. Remember, it is 10 minus 0 will still give you 10. And that gives us 5.9049 times 10 raised to negative 6. It is not bad when you leave it in standard form, or you have 0.000005. But it's not bad when you leave it in standard form. At least 1. At least 1 means 1 all the way to 10. So that means, since the whole probability must give us 1, then at least 1 is just 1 minus provided that x is less than 1. And x is less than 1, it is only 0. The only value that is less than 1 is 0. So just 1 minus probability that x is 0. And the probability that x is 0, when you just substitute, you'll get the probability that x is 0 is here. I have it here. So this is the probability that x is 0. So 1 minus the answer which is here you'll have almost 99%. At most 8. At most 8 means what? 0, 1, 2, 3, 4, all the way up to 8. So that will be a difficult task, but you're only leaving 9 and 10. So when you get the probability that x is equal to 9 plus the probability that x is equal to 10, go subtract from 1, you'll have all those probabilities from 0 all to 8. That is what I've done. So that is 1 minus probability that x is equal to 9 plus probability that x is equal to 10. I've gotten probability that x is equal to 9. That is 10 combination 9. 0.7 raised to 9 and 0.3 raised to 1. Remember, 10 minus 9 will give you 1. That gives me this probability. Probability that x is equal to 10, that is 10 combination 10. 0.7 raised to 10, 0.3 will be now raised to 0, because 10 minus 10 will give you 0, and that gives you this probability. So it is this plus this, go subtract from 1. That gives me almost 85.1%. So that's how this problem 1 is solved. Let's look at the problem 2. A survey was conducted in a certain town, and it was found that 10% of the families do not own. So our event here is a family not owning a television set. That is our event. A random sample of 10. A random sample of 10. So this is our N. That will be our N, and 10% will be our P. Selected from the sample, determine the probability that all families own. Remember now here is asking own. But what we had in the question, do not own. Set, one family does not own. So this one in Indiana does not. Two families does not, so that's okay. Less than two families do not. So that is okay. So when you look at Roman 1, it's asking own. But what we have in our event is do not own. So our N is, the sample size is 10. Probability of success here, 10% is the same as 0.1. Now, all families own television set. It will be 1 minus all do not own. So, all do not own. Remember they were 10. So that's probability of x is equal to 10. I've gotten it. 10 combination 10, 0.1 raised to 10 and 0.9. Remember 0.9 is 1 minus p raised to 0, and I've gotten it 1.0 times 10 raised to negative 10. So when you subtract this one from 1, you will have almost 99.99% of the families in that town, they own a television set. So this time at least the people's income are very okay. One family does not, so product x is equal to 1. That is correct. Just substitute 10 combination 1, 0.1 raised to 1, 0.9 raised to 9, and you have this probability. Two families, so that means x is 2. Where this x, just substitute 2, and you have this probability. Less than 2. Values that are less than this is only 0 and 1. So just sum the two. Product x is equal to 0, you will have to calculate it. X is equal to 0. 10 combination 0, 0.1 raised to 0, 0.9 raised to 10, and you have 0.349. This is a probability that x is equal to 0. Add it to probability that x is equal to 1. Remember, probability x is equal to 1, you've already gotten it here. So these are the only values that are less than 2. 0 and 1. So that is what I've summed here, and I have almost 73.61%. So that's all about the binomial distribution. Let's proceed to a Poisson distribution. And the second type of a probability distribution is the one we said is a Poisson distribution. So the Poisson, the probability distribution is given by the product x will be x is lambda. This is a Greek letter being read as lambda. It is being read as lambda. It just means the mean of a Poisson distribution. So it is lambda raised to x, where x is our random variable, e negative lambda over x factorial. In fact, factorial is also in your calculator. It is slightly below the shift button. So for you to get it, you must press shift, then that sign. It is bringing an exclamation mark. So exclamation mark in mathematics simply means factorial. So what are some of the characteristics of a Poisson distribution? First, it is a discrete probability distribution. Why? Because x will only assumes the whole numbers. It is a limiting form of a binomial distribution when this n is very large. So when n is very large, like 1,000, 10,000, then the probability of success P is very small. Then binomial distribution will tend to be a Poisson distribution. The main parameter is mean. Here I've left the term parameter. The main parameter is mean denoted by lambda. So the main parameter is mean, which is denoted by lambda, and it is given by. So how do we find lambda? Suppose it is not given, then just need to know the sample size times the probability of success P. That will give you lambda. The mean is lambda, that one I've said. So the mean of Poisson distribution is lambda, which is n times P. Variance is also lambda, which is n times P. And standard deviation is the square root of lambda, which is the square root of NP. So let's look at this example here. Poisson distribution is just direct like that. A company received an average. So remember, mean is sometimes called average. So average of 3. So automatically from here, we've known our lambda is 3. 3 phone calls every working day. In a randomly selected working day, calculate the probability of receiving no call, 2 calls, 3 calls, and 4 calls. So you only need to identify the lambda. So our lambda is 3. Then provided that x is equal to 0, no call, that means x is 0. So it will be lambda raised to 0 e negative lambda over 0 factorial. So lambda is 3 raised to 0, 3 raised to 0 is 1. E negative lambda. E is here. In fact, E is just slightly opposite the cube root. So you have to press shift is when you get it. Please just press shift, then E. Don't write raised to because it is automatically there. Then just write negative 3 and you will have a value there. If you press a raised to, it will give you a syntax error. So that is 3 raised to 0 E negative 3 over 0 factorial. In fact, 0 factorial, just press 0 then shift. That exclamation mark, you will get 1. So that will give us this probability. Prove that x is equal to 2. That is 3 raised to 2 e negative 3 over 2 factorial. Just press everything in your calculator, confirm. If you have 0.2240, the same to when x is 3, you still have the same value. Just confirm with your calculator, 0.224. And when x is 4, that is 3 raised to 4 e negative 3 over 4 factorial, you will have almost 16.8%. So in Poisson distribution, you only need to identify one value, which is the mean, the lambda. Then x will come from the questions and just substitute in the probability function of a Poisson. Let's look at the last probability distribution, which is normal distribution. So let's look at our last probability distribution, which is the normal distribution. It's also called the Gaussian distribution. It is approximation to a binomial distribution. So a normal distribution curve is looking like this. So let's talk about this curve. What are some of the characteristics of this curve? The first one is the curve is symmetrical about the mean value. So here is where I have the mean value. When I say the curve is symmetrical, that means this mean value divides our curve into 2 equal parts. The area to the left is the same as the area to the right. So if this is 0.5, this is also 0.5. So at the mean value, the curve is symmetrical. It is a bell-shaped curve. It is a bell-shaped curve. You can see it's looking like the bell. Mean, median, and mode are equal. The mean, median, and mode of this distribution are equal. The height is maximum at the mean value. At the mean value here is where we have the maximum. The maximum value is, the height is maximum at that mean value. The distribution is unimodal. Unimodal simply means it has only one point of maximum frequency, which is the mean value. It is a continuous probability distribution. The rest we have been doing are discrete, but here we are doing a continuous probability distribution because you'll be given maybe find the probability that x lies between 50 to 90. So it is continuous. The values that are between 50 to 90, you cannot list all of them. So it is a continuous probability distribution. The total area under the curve is equal to 1. So from the left all the way to right is 1. That means from the left up to the mean value is 0.5. From the mean value up to the right is also 0.5. So that the total area to be 1. Remember, it is probability. So the total area is 1. The curve is asymptotic. The curve is asymptotic to the baseline. Asymptotic simply means that this curve here, it is approaching the baseline but never touches the baseline. And in fact, there is no portion of this curve which is below the baseline. So it is approaching but never touches the baseline. So we say it is asymptotic to the baseline. The points of inflections are one standard deviation away from the mean. They are one standard, these points here, just one standard deviation away from the mean. A very note here which is going to help us calculate these probabilities, that if you are given a random variable with any mean mu, this is a Greek letter read as mu, and standard deviation sigma can be transformed to a standardized normal variable by subtracting the mean and dividing by the standard deviation. So the standardized random variable is denoted by z. And in fact, even if you look at the normal table, let me see if I have a normal table here. I show you here. This is the shape, and this is what I have here. This is the normal table. So here you will find the formula that I've just written for you, and it is z is equal to x minus x bar. X bar is the same as the mean, then divide by the standard deviation sigma. So we are going to look for this x's, then we read the corresponding probabilities here. So this is the formula we are going to use to calculate the probabilities. Let's take an example. So I have an example here. Example 1. A quantitative techniques examination was conducted for 200 students in a college. The marks scored were normally distributed. So that one you have to just go to normal distribution, because it's normally distributed with a mean of 66. So this will be your mu and a standard deviation of 5. That is the standard deviation of 5. Calculate the number of students. So this is asking the number of students whose marks were above 68 marks. How many got 68 marks? How many got between 56 and 70? And how many got below 72 marks? So mu is 66, standard deviation is 5. So they are asking us, the part 1, they prove that x is greater than 68, that's above 68. X is greater than 68. So find z. I said z is x minus mu divided by standard deviation. So x is 68, mu 66, divide by 5, you get 0.4. So this is the z, that is the z. And when you draw your normal curve, if this is the 66, then 68 is to the right of it. So above 68 is this area that I've shaded. This is the area that is above 68. That is the area that is above 68. So the z that I've gotten is going to give me the probability between the mu and the x, this area here. So just go to 0.4. Remember, I've gotten 0.4. 0.4 is here. And the probability corresponding to that is 0.1554. That's what I've written. Between the mu and the x is 0.1554. But remember, you want this side. Remember I said, from the left to the center is 0.5. From the center all the way also to the right is 0.5. But you want this one. So it will be 0.5 minus 0.1554. That's what I've done here. 0.5 minus 0.1554, I got 0.3446. So this is the probability of a student getting above 68. But how many students were there? They were 200. So if you want to know the number of students who are above 68, just 200 times that probability, and I got almost 69 students have 68 marks and above. Roman 2. Those who have scored between 56 and 70. So there I have two values of x's. The first one is 56, the second one is 7. So get z corresponding to all of them. 56 minus 66 divided by 5, you get negative 2. So in probability, there is no negative. So just take that one as positive 2. Then z2 is 70 minus 66 over 5, you get 0.8. So when you draw your normal curve, if here is 66, then 56 will be to the left of it, and 70 will be to the right. So between is that the area that I've shaded. The area that I've shaded is the area between 56 and 70. So read 2. Z corresponding to 2. So where is my 2? 2 is here. 2.0. I'm getting a probability of 0.4772. So between 56 and 66, the probability is 0.4772. And let's read 0.8. Z is here, 0.8 here, 0.2881. So between 66 and 70 is 0.2881. When you add the 2, then you get the probability between 56 and 70. That's what I've added. I've got a 0.7653. If I want to know the number of students, then I just multiply by 200. I almost have 153 students have scored between 56 and 70 marks. The last one is below 72 marks. Below 72. So what is the Z? Z is 72 minus 66 divided by 5, which I'm getting 1.2. If you draw and you check the area that you want, if here is where the 72 is, that means below 72 is from here all the way to the left, all the way to 0. That is below 72. So remember, from the left up to here is 0.5. So let's look at between 66 and 72. So just read 1.2. 1.2 is here. 1.2, I'm getting a probability of 0.3849. 0.3849. That is what I have here. Between 66 and 72 is 0.3849. So if I want below 72, I'll take this plus this. And this is 0.5. The whole of this is 0.5. So 0.5 plus 0.3849, you get 0.8849. If you want to go know the number of students, multiply by 200, and almost 172 students have scored below 72 marks. Let's look at this example 2. The age of employees in a small-scale enterprise is normally distributed with an average of 40 years and a standard deviation of 10 years. Determine the probability that an employee selected at random will be above 50 years, below 45 years, between 30 years and 55 years, below 35 years. So let's solve this. So this is the example 2, and let's solve it here. From that question, you realize that our mu is 40, and our standard deviation is 10. So Roman 1 above 50 years. Therefore that x is greater than 50. So Z is 50 minus 40 divided by 10. That gives you 1. That gives you 1. So if you draw your normal curve and 40 is in the middle, 50 will be to the right. So above 50 is this area here. That's the area which is above 50. So if you read 1, that is between 40 and 50, this area, you read it, and that probability is what? 0.3413. 0.3413. So if I want this area, remember you take 0.5, which is from the center all the way to the right, minus 0.3413, and you have this probability of 15.87%. Roman 2 is below 45. X is less than 45. So get the Z corresponding to that. 45 minus 45 by 10, you get 0.5. So here is 45. Below 45 is where this point all the way to the left. All the way to the left. So if I read 0.5, I'm getting this probability of 0.1915. So this is 0.1915 plus the whole of this is 0.5. You'll have a probability of 0.6915. Between 30 and 55, between 30 and 50, so I have two Z, the 30 and the 55. So the one for 30 is giving me -1. 30 minus 40 divided by 10. Z2, 55 minus 40 divided by 10, 1.5. So if I draw, I'll have 30 to the left of 40 and 55 to the right. So then the shaded area here, this is the area I'm looking for. So read the one corresponding to 30, which was -1. Just read 1, 0.3413, and the one for 1.5 is 0.4332. So you sum them together, you get between 30 and 55, and that gives us almost 77.45%. And lastly, below 35. Get the Z, 35 minus 40 divided by 10, you get -0.5, but just go and read 0.5. So if here is the 35, then below 35 is to the left of 35. So the 0.5, which is 0.1915, that is between 40 and 35. But remember, from the left up to the center is 0.5. So if I want this probability, it will be 0.5 minus 0.1915, which is 0.3885. And that is all about our probability and probability distributions. Kindly do more examples. More examples are online. Just practice, and if you have any problem, you can contact via the number which is provided there. Thank you so much, and I wish you well.